Okay, for this example, we're going to look at, well, on Khan Academy, it would be an interactive widget. So I made a big graph here on the left where I'm going to show my work, and hopefully that will help you understand it enough where you can move the points and get the correct answer with the interactive piece when you run into this kind of problem. Okay, first thing I'm going to do is look at the way they've written this. And hopefully after the last two videos dealing with kind of the basic layout of these sinusoidal functions and how if you look at that inside layer more layered or factored, it gets a lot easier to deal with phase shift. So I'm going to rewrite this using that breakdown of the inner layer. This would be 0.5 times the sine of, I can already tell I've run out of room. I'm going to move this over. Okay. Okay. And then in here, let's write this in a factored way. Let's pull everything we can off of the mixed number term here with the x, which would be 0.25, and factor that out of the other term as well. So in a sense, we've got the b value kind of isolated out front, and then our true c value is going to be what we'll have inside. So plus, and if I factor a 0.25 out of that, if you need to do some scratch work, it's just the value you start with, 0.75 pi, divided by that b value of 0.25, and that'll reduce as well. We'll end up with 3 pi. So this is going to be plus 3 pi on the inside layer. And then, of course, we have the minus 5, our midline, out at the back. So the reason I like to break it down and factor that inner layer is because now I know, just from looking at this, the way it's laid out, this is a phase shift. Three pi to the left. Okay. And since I know the anchor points for sine's parent function, I know how to adjust for midline, vertical shift up or down, and making the amplitude, in this case, smaller. We are going to be able to pin these points, and of course, we'll have to look at period too. So let's get going. Let me start with the midline. I feel like this, even though it's the outermost layer, and order of operations would be the last thing we'd calculate if we were just generating values or doing a table. But for graphing, I like to pin this down at the beginning. So I'm going to use just a real thin little indicator line. I'm going to make it dashed like I did last time. And it just kind of keeps my eyes in the right spot. I guess it's black. Okay. So there's -5. So the whole function is going to oscillate above and below that, like any sine curve would. But now we got to locate the anchor points. 0.5. I've seen people also put little dashed lines for where the amplitude max and min would be. And I think I'll hold off on that here because you guys can visualize pretty easily what half above and half below that would be. Okay, so let's do the next part. I'm going to grab my blue pen again here and take, normally sine goes through the midline and up, if we're talking about the anchor points of the parent function. Since we're shifting this down and also to the left, 3 pi. I don't have my axes labeled by pi's, but we do have, on the widget they gave us here, we do have, I'm tempted to just draw on this one over here. What if let's just do that. Okay, there's my midline. Sorry, I'm going to change gears and just go on the graph on the right here. And instead of midline being at, the anchor point being at the origin, it's going to be going through -5. But wait, we've got that shift, phase shift, left 3 pi. So I could take that point and put it right here. So in blue, you see what looks like a pretty typical sine function that hasn't been phase shifted. It's going through the origin up. First thing I would do after identifying my midline, and then also, having that factored inner layer so you could see the phase shift 3 pi left, I'd say, okay, that point's down here and phase shifted left 3 pi is over here. Now, I know how the progression of sine works. It's going to top out, back to the midline, bottom out, back to the midline, and there's a whole period. So really the only mystery left is to figure out what on earth is going on with a b value of 0.25. So remember that little algorithm we've been talking about for how the period and the b value are related? So 2 pi divided by b, and we'll plug that b value in. So 2 pi divided by 0.25, and another way to say that is how many quarters go into 2. So that'll reduce to 8, and you still have a pi. So the period, the overall length of the wave, is 8 pi per cycle. So if it's going up through here, because we phase shifted that point left 3 pi, it's not going to finish for another 8 pi, get back to that same spot. So 3 pi, 2 pi, 1 pi, 0, and it needs 5 more pi. So it's not going to finish its cycle till all the way out here. Okay, now another thing I like to point out, maybe I will use this graph on the left just to put a set of anchor points down for a, sine usually has a top out at pi halves, back to midline at pi, bottoms out, and then back to midline. Okay, so kind of estimating where 2 pi is like 6.28. So like I did in a video a couple minutes back over the basics of anchor points with sine and cosine, all of these anchor points are pi halves radians or 90 degrees apart, depending on, we're typically in radians. So they're all pi halves apart, or they're all equal, 4 equal steps to get to 2 pi. If a complete cycle for this graph is 8 pi, then all of the anchor points are going to be separated by 2 pi. So our first one, I'll go back to blue here, first one at negative 3 pi right on the midline. The next one's going to be 2 pi later, and because of the amplitude, remember it's only 0.5, so we got a vertical shrink. So above the midline, only 0.5, pretty squatty graph. Then 2 pi after that, it's back to the midline. Okay, so according to the labels here, negative pi to positive pi, that'd be a distance of 2 pi overall. And then 2 pi later put me at 3 pi. I'd bottom out, which would be 0.5 below the midline. This is going to be a tough one to draw. And then we already knew, but let's just double check. Yeah, that's 2 pi to get to the end there. So if I were moving these dots around on an interactive widget, this green dot I would put right here, and that green dot I would put right here at negative pi, comma, negative 4.5. And that should do it. I'll try to draw this in, but it's going to be, nope. I'll try again. Oh, that first, anyways, it'll look better on the interactive widget, but I hope that makes sense. I think the key to this stuff with horizontal, or phase shifts, I should say, but horizontal transformations overall, is to get that inner layer factored so you can see that phase shift isolated, and then deal with the b value separately, so you know how long from one anchor point to the end of the cycle anchor point is, and then that'll allow you to kind of backwards engineer those quarter steps into it. All right, good luck.